Now we're going to talk about fitting a line to the points on our scatter plot or to our bivariate data if we believe that a linear relationship exists between the two variables. And this is very important. You don't want to fit a line to points that are not linear because that's really not going to help us in any way. So the first step really is to check the correlation. Make sure your variables are correlated. Look at your scatter plot and get a good feel for whether we should be fitting a line to the points first. And then what we're going to do is we're going to fit the best fitting line to the points, okay? And we won't be able to go through quite the detail, but what you need to know is that regression gives you the best fitting line to the points, okay? The best fit line has many different names, and you should probably be familiar with all of them. The regression line, it's sometimes called the line of best fit. It's called the least squares line, but that is something we're not going to get to talk about. The regression equation, the prediction line, all of these are all synonymous for the line of best fit that we're going to talk about. The line of best fit has the form y hat equals b0 plus b1x. I do want to show you that this is kind of the same form as what you saw in algebra. Remember where you had y equals mx plus b? Okay, so you can see that they're just rearranged, but b1 is playing the role of m, and this is what we call the y-intercept, okay? So this is the same form of a line, it just looks a little bit different. So this is the y-intercept of your line, where it crosses the y-axis, and this is the slope of your line. Okay, this is the slope of your line. So the regression procedure gives you the best fit line through the points, okay? So again, here it says we can fit many lines through our sample points. If you think about that, so if we have points that say look like this, there's lots of lines we can fit through it. Okay, we can fit all sorts of lines, and what we're trying to do is fit the best one, and that's what regression does. It fits the best line, and hopefully later on in future classes you might learn the background behind all that, but we're not going to be doing that. You're just going to have to trust here that this is the best fit line. Okay, so the regression equation, the one that you get from regression, is the line that best fits your data points. Okay? Okay, so I want to remind you about the example that we did last time with correlation. We were talking about a real estate developer who was interested in determining the relationship between family income, which was X, and the square footage or the size of their homes, okay? So the home size, which was Y. Let me write home size, which is Y. And remember that they were in specific units. So this was in thousands of dollars and this was in hundreds of square feet. We took a sample of 10 families and we plotted the data on a scatter plot in the correlation section, and also determined that there seemed to be a positive linear relationship between a family's income and their home size. Namely, why was it positive? Because as income goes up, we tended to see that the square footage of the homes also increased. So our goal is now to find the least squares line, which is also called, again, lots of different names, the least squares line or the line of best fit, for our real estate data. And we're going to do this on Excel. So we're going to use our Excel output to get this value. Okay, I don't know if you can see this. Let me come back, I'm sorry. To get this line, okay? This has a hat on it because it's what we'll talk about that in a minute, but because it's our estimate of what is going on. So what we're going to do is now I'm going to show you some Excel output, just like I did for correlation. And then you'll also see some other examples in the videos that are included in Blackboard. So you'll get lots of different examples for how to do this. So let me turn over this page here. And so in the same place that you found correlation, remember when you go to Excel and you find under data, you find data analysis, you have lots of different choices. We've already worked with descriptive statistics that give you all the basic statistics for your data. We also have done correlation, and this time what you're going to click is regression. So regression is what you're going to click this time. And what's going to happen here is this box is going to open up. So usually this either says descriptive statistics or it says regression or correlation, but when you click on regression, you'll get this, okay? So I want to remind you how we set up our data, that it's very important that you set up your X data. I always write both that it's X and what it stands for and Y and what it stands for. And remember these, it's important that these come in pairs. Do not sort the data or anything like that, because this is one family, this is the second family, etc. So the data is very important, and you're going to see it even more clearly here. Okay, so when this box opens up, you are going to put the Y values. Notice that it's asking you for the Y range here. So I put B1 through B1 all the way down to B11. All this goes right here. You can either type it in, but you can also just highlight it and it'll pop it into that spot. Be careful that you need to let your Excel know that there's a label in the first row. You do not have to really click off on anything else for what we need. Then the X values are going to go here. So it's going to specifically ask you for that X range. And again, what we did is we highlight A1 through A11, and that goes right here. Then you got to tell Excel where to put the output. Okay, so the output range is where I'm going to dump all the results. And so I chose right here to start here, since it's kind of long. I put it in A15, and usually what I do is I landscape my, under page layout, I put it, instead of doing a portrait mode, I do it on landscape so that everything fits nicely, okay? But that's up to you. So I don't put it on a separate page. I put it right here on the same page so I can see everything. So here's where I usually put my correlation, and here's where I start my regression. That way I can have everything on one page, okay? I also show you here, but there's a video that I included on Blackboard that's really good for doing this. But this tells you how to make a scatter plot on Excel if you want to do it on Excel. Okay, but again, you will also be able to see that on the video, and this is just if you want to do this. Okay, but now let's look at what the results are when you include all of this. Okay, so we're going to look at what the results are when you run this on Excel. So I'm going to turn this over, and I blew up the output a little bit, so hopefully you can see it. I'm going to move this in a bit, but I usually, here's my income and my square footage. I wanted you to be able to see it on the same page, but the output that you're going to get starts here where it says summary output. A lot of what's given we won't be using in this course, and we would have been talking about R squared, but because of all the things that have happened this semester, we're not going to be able to do that here. But this is our summary output, and it looks something like this. And so what I want to show you, first of all, is the important things to us. Okay, these are called, the slope and the y-intercept are called the regression coefficients. Okay, they're called the regression coefficients. And so we have here, and luckily for you, it does say intercept. This is the y-intercept. Okay, right here. So this is B0. Okay, and this is right here the slope. Okay, so this is B1, which is the slope. So we are going to use these two values to create our line that we have. So this is going to actually give you the line. And so remember that y hat is going to be the intercept. Okay, it's going to be the intercept, which I'm going to write 4.975. I really want to do everything to 4 decimals here for our sake, but because this will make our calculations for the class much easier, so I realize I'm rounding this to 3 places. And then we're going to add the slope. Notice the slope is positive, so that's going to be 0.35, and I'm going to round correctly, 39 x. Okay, the x doesn't have a hat. So if I go back to the previous page, so this is where I'm getting this information from. We don't have to do the calculations. I'm going to go back to the first page where I ask you to give me the line, and I ask you to do that from Excel. Okay, so let's go back to the first page, and it says give the least squares line from your Excel output. So again, I'm going to write it again here so that we have it for our notes. Okay, so we have the line is equal to 4.975 plus 0.3539. Okay, now in the second part of this video, by the way, I do want to mention that there's other ways to get this line. And I want you to be able to see the regression output and how you get it. But I did include a video where you can get a scatter plot from Excel, and it'll actually give you the line, which is all we really need right now. So you're welcome to use that also. But I also want you to be able to see the output. So please do watch that video because it will help quite a bit. The next thing we're going to talk about is what we in the particular in this class are going to do with this line, how this line is going to help us. So that will be the second part of this video, and we'll continue from there.